Hello, class. This next kind of submodule, we're going to talk about fundamentals of science, actually. I think it's something that gets missing in a lot of conversations and even sometimes in research. But just fundamentally, there's kind of six pieces to the scientific method. And I'm guessing a lot of you guys have been exposed to this in high school or other science classes. The first one is pretty simple. You just observe the physical world around you. And where climate's concerned, we have observations we'll speak to over the coming semester, uh, all the way up to space and down to the ocean levels, where we observe things that are going on and make comparisons and things like that. Through those observations, then you, as a scientist, you uh, question or discover some kind of problem that you want to try and solve. And the third is pretty simple. Make some kind of educated guess as to what the answer to the question is. It's kind of like setting a baseline for whatever experiment or research that you're doing. And then predict consequences that can be observed if the hypothesis is correct. This is a little bit of a slippery slope because uh, predictions can sometimes go beyond what the scientist expertise is, and that also happens in climate science and becomes a problem sometimes. So you got to also recognize where your expertise kind of begins and ends. Um, Test predictions. So do experiments, see if the consequences you predicted are present, and then test it again. The whole key to being able to do research and experimentation is that it's repeatable. So if you do something, if you decide to go on and go to grad school and whatever you do, and you have to do some kind of research, you've got to always have data and be able to educate people on decisions that you made and be prepared for someone else to try and debunk whatever you've done. That's just science, and it's the beauty of science, to be honest with you. And there's plenty of research out there that has been debunked, and there's plenty of research that stands on its own as good scientific experimentation. And the conclusions, it's kind of the last thing you formulate. Uh, a general rule that organizes the hypothesis, predicts effects, and experimental findings. So you always have to have a conclusion to whatever your research is. And that will also be challenged, most certainly. There's plenty of times where you see scientific research that's done and data is analyzed and there's multiple conclusions, and sometimes they contradict. So it's a slippery slope, and it actually does happen in the climate world quite often. So just basically, uh, you can be a smart scientist and be proven wrong. Aristotle was proved wrong. He claimed that heavy objects fall faster than light objects, and he didn't test it. Galileo went ahead and climbed up the stairs to the Leaning Tower of Pisa and dropped a couple of objects and basically debunked Aristotle. Scientists must accept their findings even if they wanted them to be different. So you've got to be objective. There is plenty of uh, problems in the science world in general where uh, some scientists struggle with this piece of it. So you've got to be objective. You've got to let the facts speak for themselves and also not draw conclusions beyond what your expertise is. Science is on it, kept honest by knowing that whatever your conclusions are will be tested and tested many times before believed. So if you have research that's out there and it gets peer reviewed and okayed, there are times when even peer reviewed information like that, which we'll talk about here in a minute, uh, gets debunked down the road by another paper. In high profile science like climate, it happens a lot. Not only because of the politicization, of the problem, but just because there is a lot of science going on specific to the climate. A couple of interesting quotes here. I don't expect you to memorize them or anything like that. I just throw them in here. Sorry about that. Publications. So there's different sources for information, and a lot of times with the internet ramping up like it has over the last 15 to 20 years, a lot of that information ends up coming across and is not reviewed. It is sensationalized, and you end up falling into the clickbait trap of the internet. In the science world, we actually have ways that we kind of cover ourselves as far as research and review. We have journal articles. So when you go to grad school, if you go to grad school, you're going to likely have to publish a journal paper or two on research that you're doing. And that goes through a peer review process where you have 3 or 4 reviewers that have expertise in whatever you're doing. They typically are anonymous. They will pick apart your research, and it only makes it better, to be honest with you. It's not the easiest process, but it's something to hang your hat on. If at the end of the day you go through a process where 3 or 4 PhDs that are experts in your field okay the research that you've done and put a stamp on it. There's popular science magazines. These are actually not written necessarily by scientists. They're journalists that have expertise in the science. A lot of times these get politicized. And then, of course, mass media. Not a whole lot of us read papers anymore. We read blogs and things like that. TV is also something that's not as heavily used for content. Radio, but social media is the thing over the last 5, 6, 7 years that's popped up as a main source of information. And it gets a little bit dangerous because of that information. Once it makes it out there, there's a lot of people that take that information at face value, and if it's false, then sometimes it becomes falsity becomes the truth, and for a lot of people, and it's pretty dangerous. So we'll talk a little bit more about this as the class goes on. As far as climate literacy, here's guiding principles. This is the source is U.S. Global Change Research Program. These are 7 guiding principles. The first, the sun is the primary source of energy for Earth's climate system. Without the sun, we don't have what we have on Earth. There's no life. Climate is regulated by complex interactions, both land, water, atmosphere. It is extremely complex what's going on. So it's not as easy as saying, if we solve the CO2 problem, we solve everything. That's just one piece, one feedback that we get, a major feedback, but there's other stuff we'll talk about, like I've said before, land use and things like that. Life on Earth depends on, shaped by, and affects climate. Absolutely. Life as in human life, animal life, ecosystems, it all affects the climate. Climate varies over space and time through both natural and human-made processes. So that's kind of the catch-22 here is trying to be able to balance natural causes that we can't necessarily control versus human-made processes and feedbacks from each. Our understanding of the climate system is improved through observations, studies, modeling, research, all kinds of things. We've done a huge amount of research over the last 20 or so years to zero in on not only what are the effects of increasing greenhouse gases and things like that, but also how it branches over to other areas of science like biology and ecology and other sciences. Human activities are certainly affecting the climate system. There's proof. I'll show you lots of evidence throughout the semester. Climate change will have consequences for the Earth system and human lives. We're already seeing that, especially in the Arctic. I've gone up to Alaska a bunch, and most of the people I've talked to up in Alaska are unequivocal, let's come up with another term. Sorry about that. Um, they're certain that climate has changed massively in their neck of the woods in the Arctic. Um, Africa is another place I've been to where it's obvious that things have changed. So moving on, there's a couple more slides in here for climate literacy. There's something called the IPCC, Intergovernmental Panel on Climate Change. It's actually a UN program, part of the World Meteorological Organization. We'll talk about this a little further down the road, but as you go through assignments and stuff like that, you're going to hit some of the links for the IPCC. And here's the next two slides have some IPCC reports. There's no links on this one. Sorry about that. There are some links here that are interesting, and there's links within your assignments. And that just about does it on scientific theory and climate literacy.